Hey, everybody. Welcome again for another session of DynamoDB Office Hours. My name's Rick Houlihan. As you know, most of you, I'm sure, I've been doing this now for quite a while, starting to generate some good content out there around DynamoDB, data modeling and whatnot. Today, we're having another data modeling session. I'm going to talk a little bit about a price comparison service that we're going to get into modeling in a second. It's an interesting service to talk about. What we're going to focus on today is mostly, let's pull up that schema. What we're going to focus on today is really the product price comparison issue. I got a little fly buzzing around here. It's bothering me. I got to get my swatter out. But anyways, we've got it's mostly centers around products, right? Products, retailers sell products, and it's about the pricing, comparison for a given product across retailers. And that's mostly what we're going to focus on today. We'll see how far we get into the extended scheme with customers and orders and whatnot, but mostly focus around the product comparison. But I saw what's interesting is this little product types and this iterative or recursive relationship that happens on this table that will express when people are doing product searches. We'll get into that and what kind of patterns we can use to maintain those types or to visualize or model those types of relationships. But let's just get right into kind of building the table. If we look at some of the kind of basic entities we need to put on here, obviously the first one is a product. What is a product? And the various retailers and whatnot. So let's just start relating to that. We got a product item. Obviously, it'll be our first item on the table. This is going to be the product, and not a product, but a product. Products have various attributes. Obviously, there's the name of the product, and what we're really kind of interested in here is brand of the product and product type. Or product code, I guess, is the other one. Let's see if we look back at our schema. Products have a brand ID, product type code, and product name, and some other details. We're going to get into this if we have time, is how to search for products across categories and whatnot and details. That's an interesting use case in Dynamo. But again, this is a price comparison site, so we're assuming that users coming in here saying, I want to get a price for a given product. I already know what the product is. I want to get all the prices for a given product across all the retailers that are registered in this system. And we'll get into hopefully some use cases if we have some time around searching across products. But for the first set of use cases we want to maintain are these. And so let's say this is a Galaxy. I don't even know what the current Galaxy phone is. I don't even want to, let's say whatever Galaxy S10 or I don't even know, it's probably way out of date. I can tell you when I bought my last cell phone. This is going to be a Samsung phone, and product code would be probably /mobile /phone or something like that. And that's that multiple type codes that we're seeing here in that iterative relationship, right? That's this guy right here. There'd be a product type code for mobile devices, another and a subset of mobile devices on phones. Okay, and so let's go ahead and add some items to this partition to kind of talk about prices for a given retailer, for example. So if I have a retailer that sells this phone. Go. There we go. Retailer sells this phone, and this is going to be a retailer. Or let's just call it a listing, since that's really what it is. I guess it's a product listing, and this is going to have a retailer ID, and it's going to have a price. And let's say this is, and then this again is going to be a sort key value template we want to create here, which is going to be a composite key. And we're going to use, if we want it to be price sorted, right? Since that's what we're looking for when we want to query for a given product ID, we want a list of retailers by price. And so we're going to, put that as the leading price is going to be the leading component of our key. And then we're going to tack on to make sure it's unique, because multiple retailers might have the same price. We need a unique sort key. So we're going to tack on the retailer ID to this. So that should give us a composite key. We look there, that's a retailer ID is, I don't even know, I don't want to name any retailers. We'll call it R1 just generically. And the price here for this cell phone, I'm sure this is overpriced, but let's call it $500. And so this gives us a, and now one of the tricky things we got to realize here is that we've got this is like a string sortable, integer value, right? So there's a couple options you have here to deal with this. You could convert this to a hexadecimal equivalent value, which would be string sortable, but that's kind of a pain. So I would just say 0 pad it so that it becomes string sortable. So let's go ahead and do that. And so price is actually not a numeric value. It would be a string value. It would be 0 padded. And so we know that the phone will never be more than $9,999. So if we 0 pad it, then we've got it, with the actual price, we have a string sortable value there. And so that's a little kind of an annoying thing about these composite keys in DynamoDB, but it is something that we need to accommodate in the design. It's not terribly difficult to deal with, as long as you're aware of it when you're writing your code. Let's say we have another retailer in here. We're going to have a retailer 2. This will be listing. And retailer ID is R2. And now we have a price code, which is, let's say this guy is a little bit more expensive. And so he's now, if I went to this product ID and I said, okay, give me a listings for all this product, P1, which I, could be whatever Samsung Galaxy S10. Obviously, that's what it is. And I say, scan forward index false, limit 10. Let's say that gives me the product item. It gives me the first 9 listings. I'd probably say limit 11. Gives me the first 10 listings. It populates my first page of results, for example. And honestly, in this particular query, I would probably say, let's go back and say, let's let's query for more than 10, right? I mean, whatever my page can, let's query for a couple hundred or a couple dozen, figure out what about one RCU is the cost of this query. This is a lot less than 4 kilobytes worth of data right here. So I could do a limit 10 or a limit 15 and get the same, types of, or a limit, 100 potentially, and get, enough data to populate a couple pages in the UI. It's only going to be maybe 1 or 2 RCUs worth of data. And then I don't have to round trip back to the server if customers starts paging through, right? If I'm looking for, what I really want is the lowest first. This, if I do scan forward index, that's actually interesting. If I do scan forward index false limit 10, it gives me the most expensive first, right? So what I really want is the lowest first. And so what I would probably want to do here is create a key. And I'm not going to do this quickly here, so it's going to be kind of a hack, but I would want to create a key value instead of A. A puts me at the top of the list. Everything falls as a sorted order from the highest to the lowest underneath that. What I really want is A at the bottom of the list, right? So that I could say, so if I put this at, what happens if I do 0 here? Yeah, there we go. So the 0 item goes to the bottom of the list now. And so I don't need to do scan forward index. What I really want is query for product ID equals P1, limit 11. And that brings back, the lowest, from lowest to highest, as well as the product item. Okay, so if I use a numeric character here, or if I use an alphabetic character, it goes to the bottom of the list. I don't necessarily want that because if I want the lowest items first, so I'll use 0 as my key for my product item in the partition, and now everything sorts nicely with the product partition or the product item coming back first, which is really what I want in that particular use case. All right, let's think of some other access patterns that we might have here. We talked a little bit about maybe I want to get products by brand. I want to get, and let me turn on. If people have questions, feel free to throw out access patterns that you want to see. But if I want to get product items by brand and listed by price, then it's easy enough to go ahead and do that. We could just add the GSI, a brand GSI, where the primary key. Let's go ahead and create the actual keys here. I might want to reuse those GSIs for other access patterns. So what I want to do is I want all my listings to start to come back as, let's see, what we want is GSI1 PK. Let's do GSI1 SK. And we can add brand ID here. So this could be Samsung. And GSI1 SK will be our price. All right, yeah. And so we could come down here, we could say Samsung. And we actually might want to say, let's say I want all the retailers that sell a given Samsung phone, right? So let's say this would be, we would want to put this our product ID, or we could just say Galaxy S10. Let's just do that, more readable. Matter of fact, let's just make this Galaxy S10. So make it nice and easy to read. And so then again, this guy would have the same partition and sort key. And we can actually then actually price list to these as well. Let's go ahead and do that. Create one of our value templates here. Put that in here. What we really want is retailer. Oh no, we want brand doesn't exist yet on this item, so let's go ahead and add brand. And then we want price. All right, brand and price. And so let's go ahead and add brand to the retailer item. Do we need to do that? Yep. And let's add brand. And this will be, oh no, wait a second. It's not brand. It's, okay, that's a mistake. Let's just do this. Let's make that the PK. Yes. And so now, yeah, so now if I create a GSI and I go GSI1 PK, GSI1 SK, call it GSI1. Let's look at that guy. I can see, okay, if I want to get Samsung Galaxy S10s across all retailers sorted by price, I could say query GSI1 PK by Samsung starts with Galaxy S10. And, I could, of course, limit that by number of retailers. If I don't want to see more than, 25 or 50 retailers, it gives me a price sorted list of Galaxy S10s across all retailers, right? Retailer ID, retailer 1 and 2 both show up querying that particular, GSI. Similarly, I get the same thing by querying by product name here, Galaxy S10. So I'm not sure if this particular, does that help? That doesn't really, I probably want to eliminate the PK from the sort key here. I don't even know if this is a useful access pattern. Again, I'm just theorizing, but this would be basically if I want all Samsung phones by price. Because theoretically, I get the Galaxy S10, Samsung Galaxy S10 off the table, right? So if I'm querying for a Galaxy S10, I don't need to have an index on Samsung phones prefixed on, on the phone model. In this case, now, if I have multiple Samsung phones, and we can add let's say a new Galaxy phone here, that would be, say 600. This is a listing. And listing needs, and so this would be retailer 1 also sells a Samsung and sells it for $650. Oh, I need to put that in price. And it's a, what is this? This would not be, oh, I want to actually, let's create a new partition for this. Galaxy S9. I don't even know if there is an S11, but this is going to be a listing. Matter of fact, let's just cut this item, paste it here. Where do I paste it? How do I paste it? I forgot. I had the ability to do this. Yeah, there we go. So there we go. Pasted the item into there. And what this guy is, it's not a listing. He's a product. Sort key 0. This is going to be Galaxy S9, or what do we say? S11. Yes. Brand is Samsung. Okay, and now if I go this route and look at my GSI, yes. So now I'm seeing all phones, all retailers by this brand sorted by price. And so I could say, you know, give me everything Samsung phones that are less than $1,000, for example. So I could say scan forward index false, sort key less than 1,000, for example. That would bring back, you know, every item that is less than the price. And in this particular case, I don't need to use this 0 padded. I could actually go with a numeric sort key on the GSI if I wanted to. I only need to use the 0 padded numeric value here because it's a composite key, right? And when we use composite keys, strings and numbers, you know, they don't really work so well together. We need to convert everything to a string. But on the GSI, I could have a price that's actually just a numeric sort if I wanted to get all phones across, you know, the manufacturer. Let's see, what do we got? Oh yeah, how do you delete DSIs in the data modeler? That's a good feature. Let me go ahead and add that. Honestly, you can't right now. The way to delete it is to, you know, save the model into a file and then go into the file and delete the GSI spec. And then when you reload it in the modeler, it's not going to have the GSI. So, but that's actually a good feature request. Thanks for that. I'll add that. Let's see. So the 0 will be like the metadata, right? Yeah, I mean the 0, and you're talking about the 0 in the sort key on the table, right? The 0 is simply, you know, the sort key for a product type, right? The 0 item contains information about the product. Anything that has the composite key of a string sortable value or numeric, you know, with the retailer is that composite key. That's going to be a listing, right? So it's just different types of items on the table. We're going to have you know, different keys for those items. But what I want is, again, think about it from a use case perspective. When I query for, you know, get me all the, you know, do a price comparison search on a Galaxy S10, right? I want to know the cheapest of all the retailers. So, and I also need to know all of the metadata that describes the phone, right? I mean, you know, manufacturer, brand, code type, product type code, all that kind of stuff. The additional details that describe the phone, you know, processor type and all that to populate the UI. But I don't want to denormalize all that data across every listing. I only want to have one item that describes the product, and I want to have an item for each listing. And so that's kind of this one-to-many relationship that you're going to be querying. And this is kind of the fundamental construct of single table design and in NoSQL databases in general, is that we're querying on the dimension that's interesting to the application, right? It's a price sort. We want to get price sort by item or by item type or item code, so to speak. So that query in a relational database would be potentially a join of a product table to a pricing table, where, you know, retailers would have entries on the pricing table, and it would bring back, you know, a view which would have rows of data that would have, you know, basically duplicates of the product row, but it's a join that comes back. And in this case, what we're doing is not really joining the items, but we're kind of grouping them together in the partition already and sorted on a dimension using the sort key that gives us that price, you know, sorted list of retailers. At the same time, what comes back in that price sorted list of retailers is the item that's sort key 0, because that matches the sort key condition of, greater than 0 and limit 10, or there's really no sort key. There's no greater than 0. We just say query where PK equals Galaxy S10, limit, whatever, 50, for example. That gives me 2 or 3 pages worth of results. And the first item in the list is going to be the 0 item, which describes the product, right? So that's kind of, again, the idea here is we're creating a grouping, a collection of items that are interesting to the application, that are going to support a given access pattern. In this case, that pattern is by product name, sorted by price. Now, if I needed to get a different dimension, that's what we're going to set up the GSIs for. In this particular case, when I get all products for a given manufacturer across all retailers sorted by price, I could, again, this query would be, give me all Samsung phones that are, less than $1,000 across all retailers. A query where partition key on the GSI1 PK equals Samsung. I would scan forward index false, and I would say less than 1,000, and that would bring back, in this case, these 3 items. But if I had hundreds of items in these partitions, it would only bring back the first 50, right? Wasn't expecting your photo to show up. Sorry. Anyways, if any questions you guys have, feel free to throw them up on the chat there. I'm seeing those as I'm talking, and we'll kind of get to those as they come up. So we kind of went through a couple access patterns here. The primary access pattern that we were really looking to satisfy was this price search, right? Give me everything for this given product sorted by price. In our case, we're most interested in lowest to highest. That's what most comparison shopping services would be looking at. But it's a whatever is up to you. So as we get into other, drilling down through the schema, right? So we kind of covered, products, brands, retailers. We've added retailer product prices, and I don't have any top level, information for a given retailer, right? If you want to search across the data set for, hey, give me all the objects of a given retailer, we do have this retailer ID that's tagged onto all our listings, so we could collect those. We could also create some retailer partitions so that I could say, hey, give me the price sorted list if I wanted of all listings at a given retailer, along with some retailer data. So let's go ahead and create a retailer partition. This is for retailer 1. This is a retailer. He's going to have, what is his sort key going to be? That could just, again, be 0. We are going to have retailer ID. That's what we want. And we want, what else do we want on here? I think we want some GSI keys so that we can put them on GSI2, right? Because the listings are already on GSI1. Now what I want is listings by retailer. So I'm going to actually have to index the listing items in 2 dimensions, right? The GSI1 is on the manufacturer dimension. On the GSI2 will be the retailer dimension. And so if I want to have the retailer item inside of the retailer query, I'm going to need to put it on GSI2, right? Not GSI1. So even though the retailer is only indexed right now on 1 dimension, it's going to be on GSI2 because that's where the data that we want it to be co-located with actually exists, right? So let's go ahead and add that. Let's add GSI2 SK. And see, what do we want? GSI2 PK to be our retailer ID, right? Oops. That. And we want GSI2 SK to be, I think, just 0, right? Yes. And so let's go back to here. Let's add GSI2 to our listings. Add SK to our listings. And these are going to be retailer ID, right? Yes, same thing as this. Lives here. This is going to be price. And let's take a look at what that looks like. And let's go ahead and add GSI2. We'll call this GSI2. And off we go. So now when we query GSI2, I can say, hey, give me a price ordered list of, price ordered list of items that are being sold by retailer 1, including, the top level retailer item, query where PK equals retailer ID, and sort key, no condition if you don't, and then limit 50, for example. Gives me, I don't even know if there's, again, we don't know if there's a valid query. Maybe I want to get everything for a retailer that's over $1,000. In which case I'm not going to be able to pull back the retailer's item with that query. So maybe I fork 2 queries to get, if I do need that data. I might not need that data. By the time I'm querying the retailer, I might already have this item, for example. Maybe I queried the table by retailer ID. I already got this item. So I really don't care if it lives on the GSI or not. What I'm querying the GSI for are price ranked list of items by retailer, for example. So again, we're just kind of theorizing on what we would put on or off the index. In this particular case, I have the primary table, which is by product. I have GSI1 now, which is by manufacturer, right? We have GSI2, which is by retailer. Okay, so those are 3 various dimensions that I can be searching across products. Now, you think about price comparison. Really, it's more about selecting the actual item itself. You're really looking for the price ranked list. Maybe I have a couple of retailers, right, that I'm interested in. You can apply the filter conditions on a retailer in these queries, but understand with thousands and thousands of retailers, then you might end up with pages of empty data. So I'd probably want to go back to this particular query, and you know what? Maybe price isn't really the best dimension for this GSI. Thinking about it, maybe product ID is a better dimension for that. So let's go ahead and change our query here to, this should basically be what, the PK, is that right? Yes, because that is the product ID. And I don't think we really want those retailer items in our GSI, so let's just delete those attributes. And now if I go to my GSI, I can query by retailer, and I can say, okay, give me everything for retailer 1 that's Galaxy S10, right? And so really what happens when I'm doing retailer comparisons is I'm going to probably select which retailers I want to compare. And instead of trying to use filter conditions on the actual product partition, which could end up with pages and pages and pages of iterations across listings before you run into the retailers that you're actually interested in, what I would do is I'd issue parallel queries across the subset of retailers that the user selected, right? If they're saying, hey, I want to know everything at Best Buy and Target and Amazon, right? Then let's go ahead and just query those 3 retailers in parallel instead of trying to filter out the thousands and thousands of retailers that are not those guys from this list, right? Because who knows where those items live inside of this list. Alternatively, we could facet the data inside of the table partitions by product and retailer, right? If you're interested, you could do that either on the partition key or on the sort key. But honestly, most price comparison queries, at least one of those access patterns is going to want to query across all retailers, right? I mean, so again, when you get into the subset of retailers, we could say, query individual retailers for individual products that they have listed. And, they might have multiple types of Galaxy S10s with various types of, options, whatnot at a given retailer, but execute those in parallel because the user is going to select 2 or 3 retailers. And that's, those are going to be much more efficient to execute parallel queries than, paginate with filter conditions across, a large collection of listings, for thousands of retailers, for example. So this GSI2 is probably a pretty valid pattern for price comparison sites, right? I've gone into those sites. They do allow you to select by retailers, and when users do that, they're kind of cutting through, a large number of listings. So let's go ahead and, I would go with that GSI. All right, a couple more questions here. Let's see. Yes, if you want to ask questions, do you mind asking questions? They're not really related to the use case. Object versioning, should I wait for the end? No, it's okay. We can talk about this. Well, you know what? Let's do wait to the end. But I will address this question about versioning because it's an interesting use case, and there's many approaches to it. As a matter of fact, might make a good topic for another office hours session because there's a variety of use cases around versioning. Surprisingly, as I've gone through so many workloads, I've seen a lot of nuances to that requirement. But I'll talk to some of those options before the show ends today. Let's see. Can we overload GSI with retailer information? We are using strings as PKs as long as we know the semantic. Okay, so let's see. We're using strings as PK. So as long as we know the semantic use, we should be fine, right? Absolutely. You can overload GSI1 with retailer information. Let's say I wanted to get all retailers of a given type or within a given, let's go ahead and do that. Let's say I've got, let's say retailers have a location, right? Or a zip code or whatever. Yeah, location, that could be a zip code. And let's say that what I want is GSI1 PK to be that location. New glasses. Things are getting fuzzy. Either that or I need to use a higher resolution on my screen. That might be the better option. And so that the SK could be retailer ID, let's say. And so if we go down that path, if we look at the GSI1, so now what happens is we've got retailer information on GSI1. Oops, that's not right. I made a mistake there. That's not going to work. And let's add GSI1 SK. Oops. What's going on here? GSI1 SK. 2 SK. So this would be retailer ID. All right, and so now when I've got GSI1 here, I can say, give me all the products by manufacturer, give me all the retailers by zip code. All right, so maybe I want to do a price comparison across retailers. The first thing I need to do is find all the retailers that are in my local area, 78681, right? Okay, great. I've got 5 retailers, for example. Now let me go query GSI2, execute parallel queries across those 5 retailers for Galaxy, Samsung, Samsung Galaxy S10. And that'll give me all the Galaxy S10s within my zip code, or whatnot, right? We can also, if you want, you could do geohashing, right? We could say, hey, let's create, geospatial queries on my DynamoDB table. We'll talk about that. That's another topic for another set of office hours, but it's not difficult to go ahead and create geohash coordinates in my GSI1 PK and SK, and then it's a very simple algorithm to determine by distance and radius from a set of geospatial coordinates how to query the geohash, whether it's a single partition query or a multi-partition query on the GSI, on the GSI. But I just use zip code here because it's easier to demonstrate. But I'll take a note on that. I mean, people might be interested in looking at geospatial use cases on Dynamo, but the idea here is give me all the retailers a given zip code, and I can actually create, I can add listings. Let me see, well, listings are in Samsung by manufacturer. So if I wanted to have all the listings across retailers in a given zip code, then I would probably actually do that a little differently. I'd create GSI3 on the listings, for example. That would probably be a more, let's say, give me everything within my given zip code. Yeah, location. I need that. And then this is going to be GSI 3 PK. And GSI3. Okay. See, these overloaded use cases on things like retailer, in this particular example, they don't really help us much because, yeah, I can query GSI1 now and it's overloaded. It gives me, I can query retailers by zip code, but I already have listings by manufacturer on GSI1. So I can't really add listings by zip code on GSI1. I have listings by retailer on GSI2, so I can't add listings by location on GSI2. I actually have to add GSI3 onto the listing items. And for this workload, it actually kind of makes sense because what I'm really interested in is price comparison, right? It's all about price comparison. It's only on the different dimensions of comparison that I'm going to be querying, which means that each one of these listings is going to have a category or an index on every dimension that I'm going to be querying for, which is, that's not unique to NoSQL databases, right? I mean, I can query tables in a relational database without indexes, but it hurts me. You also want to limit the number of dimensions that I'm allowing people to query on, right? In any kind of database, right? Whether price comparison or not, because the right cost that you pay to maintain the data is high if I'm indexing lots of columns, right? So, but in this case, these are all useful dimensions for us. So let's say we have 2 retailers in my location. We have, so all those listings are in my location. And let's go categories. There we go. And the GSI3 PK is going to be our location, right? Yes. So let's go here. And the SK will be price. And so now if we add GSI3, which is totally irrelevant, use case, right? Give me everything in my zip code that is, sorted by price. I might want to be interested in going to pick something up right now. This is GSI3. Create that. And what we end up with is, oh, that's not the view I want. I want this view. And so, yeah, now when I query by 78681, I get a price list of listings within my zip code for the, well, that's across all objects. So I actually probably want a different key. I probably want not just to be price. I want this to be, what is it? No, the PK is really what I want because that's the product ID. And that's right. PK hash price. That's right. Okay, so now I have if I query GSI3, I have, starts with Galaxy S10. I'm going to get all the Galaxy S10s in my zip code sorted by price. So on and so forth. Starts with Galaxy S11 or any other product ID. I'll have all the products within my zip code across all retailers. Right, so I can decide where I want to go. Let's see if we got any more questions. How is DynamoDB different from Apache Accumulo in respect to schema design and working with it? Well, I can't comment too much on that because I'm not familiar with Accumulo. But I'll answer you that question on Twitter in detail. But the one thing I can tell you is I don't think Apache Accumulo is offered as a cloud-native distributed backplane service with the elastic just-in-time provisioning, right? That's obvious differentiation is that you're going to get the ability to kind of add capacity on the demand. You're going to pay for storage only when you insert the items. When you delete the items, you don't pay anymore. So it works differently than any other legacy technology or technology was built to deploy on legacy infrastructure, right? This is always how I talk about cloud native first. You kind of want to look at, does it fit your workload? Not, what are the features differentiation so much, because it's not about that. It's like, what does the workload require? If the workload doesn't require the features of a given platform, then use what it needs, not what you'd like it to have to require, right? I mean, really, the only thing that pays the only victim of arbitrary requirements, I think I sent a tweet out about this, the only victim of arbitrary requirements is your budget, right? So let's make sure that we're designing for the requirements we need. But I actually interesting. I haven't actually looked at Apache Cumulo, so I will be happy to look at that and watch my Twitter. I'll try and respond to that particular question. What's the biggest thing you've ever stored in DynamoDB? What's the biggest thing I've ever seen stored? Okay, Galaxy Sync Service, Samsung's Galaxy Sync Service. That was our first 100 petabyte table, I think. Is there anything bigger? I'm not sure if there's anything bigger. That's like the biggest thing in my mind. There may be bigger workloads. I know that we have that Samsung is a huge customer of Dynamo, well documented, well referred. There are other customers with larger workloads. I'm not sure if I can publicly disclose, but as far as scale goes, 100 petabytes is pretty big. I don't think there's any other NoSQL database on the planet that's gotten to that level of scale. Oh, wait. Interested in geohash searches? Yes. Okay. Looking forward to a future session. Absolutely. I've heard, there's a James Beswick actually put together. He's one of our developer advocates for serverless, put together a really nice blog post on geohash. Go ahead and search for that in the meantime. And I'll probably be dissecting that and using a lot of his, techniques when we do that session. Yeah, that's big, 100 petabytes. Comment on when to overload a GSI versus creating a new GSI. Okay, I just talked about this, and it's actually very relevant in this particular model because, honestly, again, the only thing I'm really interested here is in listing items. I don't really care about any other items. In this particular case, we created an overload to get all the retailers in a given zip code. But I also have the GSI3 to give me all the listings for a given product in a given zip code. So that's where we actually start talking about overloading, right? So if I have multiple types of items that need to be indexed, then they can both share the same index, generally speaking, unless they're accessed on the same query, right? And if they're accessed on the same query, then potentially there's no overloading of those particular objects because that's the pattern that they suffice. Now, let me demonstrate that. In this particular case, we have retailers, we have prices by manufacturer, right? So let's say for some reason what I wanted all the retailers to come back as well when I queried by manufacturer. Give me all the retailers that sell a given device, okay, as well as all the listings for that device. So I could say, okay, let's add those retailers to GSI1 PK, and what I would want to do here is say, what is GSI1? GSI1 is my manufacturer. So this retailer essentially has multiple records. He has one for each manufacturer that he. Let's see, is my keyboard working? Yes. Let's say he sells Samsung. And so this is the 0 record for this manufacturer for Samsung. Why am I seeing this? This should be 0. Yes. And so let's say we have, what's happening here? Oh, my model's tweaking. Do I have? Oh, that's because this, okay, so I can't change that because I need to add a manufacturer. Yeah, this is not a good example. I'm sorry. I thought I had a good idea. It was not a good idea. But let's get back to the question. Could you comment on when to overload a GSI versus creating a new GSI? If I have access patterns across multiple dimensions, across multiple types of objects, then they can be overloaded. In this particular example, I already have an index. I have GSI1. It exists to get items listings by manufacturer. If I had an additional pattern that says, okay, I want to get retailers by location, then I don't want to create GSI4 because retailers are not indexed on anything yet. right? I can add keys to the retailer to overload that access pattern onto GSI1 and essentially reuse this index. And the reason why I'm doing that is because, you know, as in DynamoDB, you allocate capacity to each individual index. If you share multiple patterns on an index, essentially you're kind of reusing the capacity across your patterns. You're increasing the overall utilization of the index. You're reducing your cost. Now, the other way to go is say, okay, one access pattern per index. I could say, well, let's not make this GSI1. Let's make this GSI4 PK, and let's add GSI4. But as you can see, that means that these items now here, all the retailer items, they're just going to get shunted off to another index that I'm going to have to create, you know, capacity allocations for. I'm going to have to manage that, you know, index. And, you know, whenever this pattern is not being used, nothing else is using that, you know, that bucket, so to speak. So if it's an on-demand table, on-demand indexing, you know, not a big deal, because the price is the price, whether it's one index or many. But if you're starting to allocate capacity for each one of your indexes, it can become, you know, it'll increase your overall utilization to do that overloading. So that's, I guess, the long answer to a short question. And maybe the shorter answer is, you know, whenever you can. Right. I guess that's the best answer to when should we overload. Whenever you can. All right. Anything else? Okay. Looks like no more questions right now. See if we can go back to our schema and look at any other patterns that we might want to start to express here. You know, in this particular example, again, the primary access pattern is pricing by product. You know, that's what we got on the table. We get prices by manufacturer on the GSI1. We get items by retailer, right? Listings by retailer on GSI2, and then we get listings by zip code on GSI3. If we go back and look at our schema here, there's a whole bunch of other stuff going on. We have special offers, right? So special offers is something we want to start to inject, so to speak. And I would actually inject those. Where could we put those? I would probably put those on the listings, right? I would actually just add an additional attribute. Yeah, that probably makes the most sense. Yeah, add an attribute onto the listing that would be, you know, special offers, right? I mean, how much data is that going to be, right? Not much. And it's probably going to, you can have multiple types of offers. They just live inside of a map attribute here. And, you know, you don't have to, you know, worry about creating additional items for that. I don't see why I would want to query only for items that have special offers. Right? If anyone can think of a use case for let me query for only things that have special offers, then let me know. But I think really what I want to do is I want to display the valid offers when the listings are retrieved, right? So I'm going to say, hey, depending on, give me all the price comparisons for the Galaxy S10 across all retailers. I'm going to want to see whatever offers are active, and that should come back in the same query. I'm never going to be querying for offers independently. I don't know, maybe I would, but I don't think so. Yeah. I would just put offers, special offers as tacked onto the end of these items, I guess. And then that might require that some of these offers get denormalized, right? I mean, if you think about what is the offer, 10% discount on all Samsung phones. Okay, well, guess what? I'm going to have to put that special offer on every listing for every Samsung phone for that retailer. But how many retailers, how many offers are there, right, for a given retailer, right? You know, how many listings are there for a given retailer, for a given, you know, it's for Samsung phones, right? Not thousands, right? Maybe dozens, right? So it's not terrible to denormalize that data. And again, once the offer expires, it's irrelevant. It's kind of just dead data on the end of the item, and you know the listing is likely to expire, you know, at some point, which will remove it from the table. So that's probably where I would go. Does the Amazon DynamoDB client from the AWS SDK use HTTP1 or HTTP2? That's actually a good question. It's probably in documentation. I'm pretty sure it's HTTP2, but that would be something that I would want to verify. Maybe I noticed Kirk's online as a moderator. He can probably look that up for you real quick. Let's get back to the question about, what was it? Question about object versioning. All right. So the question was, do you mind, should we talk about object versioning? Is there a specific question you have, I guess I should say, or should I just talk about it more generically? What is the use case for versioning that you had on your mind for that particular thing? But I can start talking about versioning generically. Typically, what we'll try and do when we have object versions is there's really two approaches. We can create a current version, an active version, so to speak, and using a prefix on a composite key. And let's just go ahead for this example's sake. We can talk about what might I want a version here. Let's say we had versions of a retailer. Let's go ahead and do that. So the retailer's initial or current active version might be v0, right? And so maybe someone comes in at some point and he starts editing this data for this particular retailer, and he changes some things, right? So let's say this retailer's retailer ID is still R1. He's maybe changed locations, right? Moved to a new zip code. I don't even know, 683. Who knows? Cross town. I don't even know if that's a cross town. And at some point, we're going to edit some other data. At some point, we want to commit this data, so to speak. What I would do is I'd say, okay, actually, this is different. So what happens here is the first version gets created as v1, and when we copy it to v0. So essentially what you have is two items here that are duplicates, v0, v1. Whenever I want to get the current version of the retailer, I come in, I say, give me R1, retailer ID is PK, and it starts with v0, or sort key equals v0, brings the current version. Somebody comes along at some point, they create v2. I kind of started out of order here. So now we've got v2, somebody's working on v2. We've got, a v2 item here. He changes his zip code, moves across town, right? And we're going to go ahead and commit this at some point. We're saying, okay, we're done editing v2. Let's go ahead and commit that data, and we're going to clobber the v0 item. Is really what we're going to do. You're going to create a copy of v0 over the top of v1, right? Or a copy of v2 over the top of v0. So now what I have in this partition, I have a version history of this item, right? I have the current version, I have the first version, I have the second version. Somebody comes along and creates v3, we'd go through the same process again. Eventually we clobber v0 with a copy of v3, and that gives me the ability to kind of edit items without impacting the active version, so to speak, right? So nobody will see my changes in the application layer until I decide it's time to apply them, at which point I clobber the v0 item. I can do that in one of two ways, right? I can actually add a flag onto the end of these items, and I can call it committed, right? So let's say, commit flag, and this could be true. This could be, these are all true. These are all true. And when I flip the flag, now let's say I create v3, right? v3 is created. And, this is going to be another retailer. And, he moves again. I don't even know where he moves, across the state, who knows? And so this is not committed yet, okay? And so when I'm done editing, I go ahead and I flip this flag to true. When I flick that flag to true, streams and lambda actually is the one that clobbers v0 for me, and that guarantees that the update occurs, right? I don't have to, and then this way, if anyone ever reads the partition and sees a false, item, then they know there's a version update in progress, right? Before I go and create a v4, I want to make sure that there's no, commit false or commit trues, right? For example, so I can set the flag here to false if it's as long as it's all true, and then whoever reads this v0 item knows that there's an edit in progress, but this is the current committed data. Then when I flip this flag to true, right, lambda comes back, clobbers this v0 item with a copy of v3 and says it's committed, right? So this way you can kind of manage that read committed, read uncommitted, and kind of simulate, so to speak, the ACID semantic that developers are so used to. I'm not sure if that's the version discussion that you were interested in talking about. We can let me see if I look back through the comments now for a second, if you had a chance to ask a more specific question. I currently fetch the v0 object. Okay, so let's see. This might be post versioning. I currently fetch the v0 object, get the current version, store the new version, and update v0. It felt a bit dumb to do it that way. No, not really. I don't think it's dumb. As a matter of fact, it's kind of smart, right? Because you're kind of editing the object behind the scenes. Eventually, you're committing the object, right? So, I mean, that's not a. I think that's actually that you kind of answered your own question, or you're kind of doing a similar process to what I've just described here. What I like about this is that the version history remains, on the table if it needs to be online and active, right? But the other thing here to potentially do is add a TTL attribute, and if we TTL. Let's say we're never going to TTL the v0 item, but so we can just go ahead and remove that attribute from only the 0 item and leave it on the others. And then here we can just have an ISO date in there. It's actually a Linux Epic timestamp, not an ISO date. Sorry, but so whatever, I don't even know that these items would expire on. And as I create versions, maybe I just don't have a TTL value here, or this TTL value here is so far in the future that it will never expire, and I leave the most recent version, or maybe I just let them expire, and it doesn't really matter, right? And then I can add, a version attribute to the top level here, and it doesn't need to exist on any of the others. I should be able to add an attribute only to the item. That's another feature I need to put into this place, into this tool. But now I know the current version is v3, and these items TTL out over time, right? So they kind of fall off the table. And if I want to get the version history, what I can actually do is as these items TTL off, they can be stored and processed by streams and Lambda, shoved into Parquet files and pushed up to S3. Right, so I can query the version history with Athena. So I don't necessarily need to keep the version trail online like this, but maybe I want it. It all depends on what your use case is. If I want high velocity access to version history, I want that low latency response time, then let's keep it on the table. But otherwise, as we kind of change those versions, and then of course you don't necessarily even need to have a V1, V2, V3. You can have an A, B. Right, so we can have an A item and a B item. The B item only exists when I'm editing the data. Once the B item commits, it clobbers the A item, and I delete the B item. Right, and somebody else comes along, or I can just leave the B item for somebody else to edit. Right, for example. But I'm always reading the A item. So lots of different ways to approach versioning. But this is a one discussion. Hopefully that was helpful for you. Good point about overloading GSIs. Provision throughput more efficient, but for on-demand, no price effect. Absolutely. I don't know. I mean, again, it's plus or minus, right? I mean, does it make more sense or not? I think once you get your head around, the idea that the data just lives on the table and it's keyed on different dimensions, it doesn't really matter. They kind of got to get out of that third normal form type of way of viewing the world. It gets easier. So I wouldn't hesitate to kind of embrace that view of the data, but it's not, certainly if there's no impact from a pricing perspective, it doesn't hurt you. Remember, you only do get 25 GSIs though, so eventually you can run out of those, and they do become kind of a pain to manage. So I always try and minimize the amount of infrastructure I have deployed in prod. Recommend a client not to use DynamoDB. Yes, it's not the one size fits all for all use cases, right? If you don't have well-defined access patterns, if you need things like index intersections and complex filtered queries, then Dynamo might not be the best solution for you, right? I mean, but let's talk about it, because oftentimes those filtered queries are not so painful if the scope of the data that I'm querying across is not large, right? So let's it all depends on the scale of the use case and the type of the access pattern. Right. Dynamo is great for scaling to infinite, dimensions on particular patterns, not so great on others. Right. So let's, I couldn't tell you which right now. It depends on what your use cases are. but there's a few. Anyways, guys, we're running up to the top of the hour here. I really hope that you guys got something out of today's session. I know it was a little bit slow starting. I'm feeling a little slow right now. I'm ready for vacation. I got a vacation coming up in 2 weeks, and I'm really looking forward to it. But in the meantime, we're still plugging away. So thanks, everybody, for taking the time out of your day to join us. And, again, if you have any ideas for future sessions, please feel free to ping me on Twitter. My handle's right there on the lower right. And again, thanks, Kirk, for showing up again and moderating. And we'll talk to you all later. All right. Bye.